Hey guys, in this video we're going to be talking all about something called bias, and that is our important vocabulary word for today. Bias is an error that results in a misrepresentation of a population. It can occur in the way a sample is collected, the way a question is asked, or how data is represented. Let's take a look at each of those types. Let's start with the bias in samples. Okay, so here's our example. Before the 2010 election for members of the U.S. House of Representatives, pollsters called American households on their landline phones to see how they planned to vote. All right, so first of all, who is or what is the intended population? The intended population would have to be American voters. Okay, now the sample would be whoever answers this survey that they're conducting here, which is exactly what type of sample method we have here. This is a survey. They are calling to ask how they plan to vote. All right, now here's the big key here. What potential bias exists in the situation? And you have to really hone in on what is going on in this, the way the sample is being collected, to figure out what is wrong here. And the biggest thing that stands out to me is this word right here, landline. Now, I don't know if you guys even know what a landline phone is, but it's that phone that is actually hooked up to the wall and plugged in. It's not a cell phone of any type. Most people these days, and even in 2010, did not have landline phones anymore. A lot of people have moved just to cell phones. So anyone that doesn't have a landline phone has no chance of being part of this sample. So we're going to say that the potential bias is that the pollsters only called landline phones. Okay, now it's important to understand as well whose interests could be served from the bias. And there's several different answers that you could get from different types of bias. But for this one, when I think about who still has landline phones, or even back in 2010, who would still have landline phones, and I think of the population of older Americans. Most young Americans don't have landline phones anymore. So the interests that are being served are older Americans, because those are the people who have the landline phones. And this creates a bias because older Americans may be more likely to vote in a certain way, just because they are all of the same generation and maybe have more similar beliefs. That might not be true, but it is definitely a possibility because they are all of the same age group. Okay, so this last little paragraph here is just a side note. It's a key piece of information. So to avoid bias in samples, you want to always make sure that you create a sample that allows every member of the population to have an equal opportunity to be selected as part of the sample. That doesn't mean that everyone does get selected, because then you wouldn't be using a sample. You would be getting data from the entire population. But everybody has to have an equal opportunity to be selected, okay? So a way that we could fix this sample is to simply not call landline phones. Instead, you could call mobile phones, or call mobile and landline phones if you really want to cover your bases. You could send a questionnaire in the mail. Most people have the ability to get mail. So that would be a way to avoid the bias that is in this situation. All right, let's take a look at bias in the way a question is asked, okay? All right, so a survey organization wants to see what % of New York City citizens supports a ban on soft drinks. The question posed is, do you support a ban on soft drinks which contribute to heart disease and tooth decay? All right, so what is the intended purpose of this question? The purpose is to figure out, it's right here in the question, what % of New York City citizens support a ban on soft drinks? So that's what I'm going to say. What %, or to find, rather. So to find what % of New York City or NYC citizens support a ban on soft drinks. Okay, Then it says, what is the potential bias in the question? Now, the bias itself is the second half of the question, where it tells you which contribute to heart disease and tooth decay. So the potential bias is stating that soft drinks contribute to heart disease and tooth decay. Okay, so stating that is trying to convince the person who is answering your survey that soft drinks are bad and therefore you should support the ban. Okay, so thus it answers the question right here: whose interests might be served in this bias? It's the interests of the people who want to ban soft drinks. This question is geared towards getting people to say, yeah, we should ban soft drinks. So those that want to ban soft drinks would benefit the most from the way this question is worded. Okay, and then again, this is just a key note down here at the bottom. To avoid bias in your questioning, avoid using words that attempt to sway the opinions of the members of your sample. So, can we fix the example above? It's very easy. Just don't say which contribute to heart disease and tooth decay. If the survey organization here had just said, do you support a ban on soft drinks? ? And then stopped right there, this question would be perfectly fine. They would not have any bias in their survey. Okay? All right, so let's take a look at bias in data representation here. We have two graphs here. Each one represents a different soccer player who play the same position but on different teams. They make a graph that shows the number of goals scored throughout the season for each player. And then the graphs are shown below. So player number 1 on one of the teams is here, and player number 2 on a different team is right here. Okay, so the intended purpose of this graph was simply to compare the number of goals scored by each player. Maybe this is being used to judge which player is better, who should be the MVP, or maybe it's being used for draft purposes, or whether or not a player should be named to the national team. Various different things that are going on here, but it is comparing the number of goals scored by the two players, okay? All right, so let's take a look at the two graphs and name any differences that we see. All right, so I noticed that the x-axis here represents the number of months since the start of the season. It's the same for both. Total goals is the y-axis. It's the same for both. The scale for the x-axis is the same in both, but the scale in the y-axis is different in both. Player number 1's is going up by 5s, and player number 2's is going up by 10s. So that's a difference. The scale, the y-axis scales are different. Okay, now if I take a look, it looks like each player has a certain number of goals tracked for each of the first 8 months. So really the only thing that's different here is the y-axis, which might not seem like a big deal, but let's take a look at how the differences affect the data. So if you look at the graph without thinking about how the scale is different, it looks like player 1 scores more goals than player 2. But in reality, after the 8 months, the 8th month of the season, player 2 has scored 30 goals, and so has player 1. So really, if you took a look at each of these points here, so 5 is at 50 or close to 15, and it looks like it's about the same here. These two players are very, very similar, but the graph makes it look like player 1 is better than player 2. All right, so how do the differences affect the representation? The graph appears to show that player 1 scores more goals, or scored more goals, but both players actually scored about the same. So then let's talk about whose interests might be served from this misrepresentation. It really depends on what these graphs are being used for. But really, player one's interests are what is being served here. It makes it look like player one is better than player two, even though that's not true. So the interests are for player one. Player one's interests are being served. Because the graphs make player one appear better than player two. And again, we don't know what these graphs are being used for, but simply the fact that it makes player one look better means that their interests are being served here. All right, we have one last problem to take a look at. Okay. The graphs below show how the number of burglaries changed in the United States during 2009. We have two different graphs here. One of them compares the months of July and August to all of the other months, while this graph shows each month individually for that year and the percentage of burglaries in 2009. Now, both graphs are supposed to show how the number of burglaries have changed throughout the year. They're supposed to represent the same amount of data, okay? So the intended purpose here was to show how the number of burglaries changed each month in 2009. Okay. Now the bias in these graphs is in this first one here. Okay. So in the first graph, it is comparing 2 months versus all of the others. So it makes it look like July and August have significantly more burglaries than all of the other months. But if you look here, July and August, while they are higher than the other months, they're not significantly higher. In fact, if I take a look at these two and I compare them, it kind of looks like what they did here was they took the month of July, which was above 8, somewhere between 8 and 10, and added it to the month of August to get 18. At least that's what I think they did. But it says all the other months are 8.2. If I added up all of the other months, I would not get 8.2. Because each and every one of them, with the exception of February, are right around that 8% mark. So it looks like they've said all the other months are about 8.2%. But then for July and August, instead of just stating where approximately they are, they added the two together. So that's an issue here. It's misrepresenting the data to make it seem like burglaries are way worse in the months of July and August. Okay, so the bias here is that the first graph makes it seem like July and August have significantly more burglaries. By adding their percents together. And that kind of goes along with part C. How do the differences in the graphs represent the data? So it looks like July and August have many more burglaries than all other months when they are really only slightly higher. All right, now whose interest might be served in this misrepresentation? It really depends on what these graphs are being used for. So say some alarm system company comes to your house and is trying to sell you an alarm system. If they're showing you this first graph, they're basically lying to you, trying to get you to buy their product, even though they're not being 100% truthful here. Okay, so you could say something like that. It could be the interest of people selling security systems, those types of things, or it really could just be a group of people trying to create outrage over how many burglaries are happening here. Okay, so I'm not going to write anything right here. You just really have to think about what these graphs are being used for and whose interests they would serve because of the bias in those graphs. All right, so again, one last little note here. To avoid bias in data representation, always make sure to represent the data in a way that is equal. Use the same scales, make bars in the bar graph the same size, etc. So you don't want to combine only 2 months right here and then put all the other months right here, especially if you're going to add the 2 months together here, but then leave the average up here for the other months. That is a huge discrepancy between what's going on in this graph compared to what's going on in this graph. Okay? And that's it. That's how bias can affect the way in which we use population and samples.